Hello everyone, you are welcome to lesson 5, of binomial theory. In this lesson we are going to consolidate our understanding on this particular lesson, binomial theory. So we are going to make use of all that we've learned, under this particular topic so far to deal with some general, example questions that may be a little or quite different from what we have dealt with so far. All right, so stay with me whilst I do them. Please don't hesitate to let me know anytime you have any issue with whatever I write or say. All right, so quickly let's look at what the question 4, or our first question in today's lesson, which happens to be question 4. So what is the instruction? Expand the following using the binomial theorem, A in ascending powers of x and B in descending powers of x. As for ascending powers of x, that one we know. We've handled question that dealt with expansion in ascending powers, but we've not done that of what the descending powers. So basically we are going to dwell much on that. But this one, if you know how to expand, it's just one or two information that you need to be given. So once you are given, you should be good to go. So how to deal with it smartly. So this is it. All right, so as usual, when you read question, underline the salient parts, if any. Then so the first one, A, is ascending powers. B, we underline what? Descending what? Powers. So we have about how many? 4. To do that. So I am going to handle it this way. I will take I, then do it for A and B. Somebody can take A, then do it for I up to IV, then maybe B, do it for I up to what? IV. I am going to take I, do it for A, arrange in ascending order or powers of X, then B, arrange in descending powers of what? Of X. Irrespective of which direction that you go, you should answer the number of questions that we want you to answer. So obviously you know I will do this too. This is in red probably for you as an assignment. And this green means likely you will see it in your class test. So take note. All right, so question number 4, solution. That's the first thing that you write. Question number 4, I will do I, then come and do A. So IA, or even I. Yes, let me go for IA. IA, what am I giving? I'm giving 1 plus 3x, all to what power? To the power 4. So I need to expand this. A is asking for ascending powers of what? Of x. So you don't have to come and write ascending powers of x. Please take note. Just write what I have written here, or you can ignore the given, but this must only be written, or can only be written. So at this point, take note, in every binomial, if you have A plus B, to the power n, and you are expanding every binomial, the powers of your A, your first term, will be what? Will be decreasing. Do you agree? So it will be in descending order. Do you agree?
Yes,
Princess,
please.
are you there? And the powers of the B will be in ascending power or powers. Do you agree? Prof. Miles.
Yes, please.
Sir, please, your screen is blurry.
Please, is that so?
Yes, sir.
Yes, please.
Who can see my screen clearly? If one person can see my screen clearly, then please disconnect and reconnect. It's coming from your end, your network, not mine. I can see quite a number of you are saying that you can see clearly. So please disconnect and reconnect. Maybe you come back with so that's it. Yamieni, I guess you can also see clearly, so I can continue. Those who cannot, please hurry up. Disconnect and reconnect. And if you come up with a good network and you can see, you give me a thumbs up. All right. So now this is it. I was saying that your first term in every binomial expansion, our first term the powers will be what? Decreasing. The second term the powers will be what? Increasing. So if you look at this critically, Okay, if you look at it critically, you see that the powers of the one will be what? Will be, if you expand in this direction, the powers of the one will be decreasing. Whilst the powers of what? Of this one, this term which contains the x term will be increasing, which will be in ascending order. Is that clear? So it means with this one, you just need to expand directly. And if you expand directly, your arrangement or your expansion will come in such a way that the powers of x will automatically be in ascending powers. So by that, I will come and write this is equal to, I thank God, okay, my first term is what? 1. And my exponent is positive. So obviously, I can use the combination what approach or the combination formula for binomial theorem. Binomial theorem involving the combination. I won't quote it, I will use it mentally. Those of you who want to quote it, if you are not mature, you come and write, but 1 plus x, okay, u, because the first term is 1, is equal to where n combination 0, okay, you do all that. Okay, then so you know, but in actual fact, if you use 1 plus x, I've told you that to give you 1 plus then n combination 1, because in that expansion, your first term will always be 1. So in this case, I'm going to write 1 plus n combination 1, but my n is 4. Okay, combination 1. Okay, then my x, but my x here is 3x, so 3x. Then plus n combination 2, so 4 combination 2. Okay, my x here is what? 3x, so 3x, okay, squared, because it will be s squared. Then plus n combination 3, so 4 combination 3. Okay, then your x cube, but your x here again is 3x, okay, cube. Okay, then plus, okay, 4 combination 4. Okay, then you get what? Your x to the power 4, but your x again is 3x all to the power 4. My professors, I hope you are following.
Yes,
My
please.
professors, are you
Yes,
following?
please.
Okay, very good. So
Yes,
at this
please.
point, okay, you use your calculator to do the combination and put the powers inside. So this will be equal to 1 plus any number combination. 1 is the number itself, so you get what? 4. Then to the power 1, if you put the power inside, you still get 3x. Then plus 4 combination 2 will give us,
6.
okay, so you are going to get 6. Then you push the power in, this will give you 3 squared, which is 9, then x squared. Okay, then plus 4 combination 3 will give us what? 4. Am I right? Okay, 4. Then 3 cube, which is what? 27. Okay, then your x cube. Okay, then the last term, 4 combination 1 is 1. I will choose not to write it. Then come and write 3 to the power 4, which will give us what? 81. Am I right? Am I?
Yes, sir.
Okay,
Yes,
so 81, then x to the power what? 4. Okay, so you come and remove your final bracket. So in this case, that would be your last step. So last step, I will write therefore 1 plus 3x, oh sorry, yes, 3x all to the power 4 will be equal to, and then don't write therefore in ascending powers. Your arrangement will bring out that fact, whether, okay, what you have there is in ascending powers or not. So therefore, you have 1 plus 12x. So let's go. Plus, my professors, you know these calculations are for you. Help me. Let's make the class interactive. What's s squared? My professors, are you there? Hurry up. Let's go. We have more to cover.
54x squared.
Okay, so 54s squared. I like that. Okay, so the whole class, let's go. 4 times 27.
108.
Okay, 108, then s cubed, then plus 81. Okay, s to the power 4. Okay, so at this point you are done, and you can obviously see that your expansion here is in ascending powers of x. The power 1, here it will be 0, only that is x to the power 0, don't write it. So 0, 1, 2, 3, 4. So your expansion has been done in ascending powers of what? Of x. So now let's come and look at the b. And you are moving from a sub question to another sub question, so I leave a line. Okay, so b. B again, we are giving, okay, it is the same binomial that you are expanding. However, in descending powers. Okay, so because this question came in this way, if you want to be smart, okay, this is what we are going to do, or this is what you can do. But I am assuming maybe you've not been asked to do A. Okay, so if you've not been asked to do A, okay, and you have this question, how do you deal with it? But in this case, we've done A. So if you've done A and you are asked to do this, and the arrangement is supposed to be in such a way that okay, your powers of X should be in descending, then it means you are supposed to move in this direction. Where is my okay? So okay, it means you need to move in this direction. The B is looking at the arrangement in this direction. Okay, so you move in this direction and write 81s to the power 4, okay, plus 108s cubed plus 54s squared plus what 12s plus 1. So that will be the arrangement here. Is my point well made, or I should come again?
Sir, please come again.
Okay, so it's the same way. Usually when you are counting, you count up. So if I ask you to count up and it is 1, 2, 3, 4, up to 5. And I ask you to, so this one, counting is done in ascending order. Is that not it? If I ask you to count in descending order, meaning count down, you count in this direction. Is that not it? You get the point, right?
Yes.
Okay, so in the same way, if I know how to expand in ascending powers and I'm asked to give the same expression, binomial, okay, and expand in a different direction, in this case, descending powers, the descending direction, then it means I just have to arrange, okay, or write in this direction. So in this case, my first term will be this, second term, third term, fourth term, fifth term. Okay, will be what we have here. However, like I said, I'm going to treat this one as if, okay, we've not done the A. And let's see whether we end up getting this expansion in this order where we are reading in this direction. Is that clear, my professors? Is it clear now?
Yes.
Okay, so now this is what you do. Because you know, okay, when you are giving this, your first term, okay, the powers will be decreasing, and your second term, the powers will be increasing, and your variable happens to be in the second term. You know that if you expand straight away, where your second term is the one that contains the variable, you expand straight away, you get your expansion in, okay, ascending powers. Okay, so if you didn't think before writing and you expand and get this side, I'm talking about this particular question, please don't cancel it. Just come and write equal to and rearrange and move your, what do you call it, your terms in this direction. Let me see if you can see can you see the cursor? It looks a little faint to me.
No,
Okay,
please.
okay, so if assuming you didn't think before writing and maybe you expanded your usual way, don't come and draw your conclusion this way. Because if you end here, you are doomed. Because the question said your final answer, okay, the expansion must be in descending powers. So you will have one more step. So it means there is a cure for you not thinking before writing. So you come and write equal to. Okay, then what do? You now, okay, write your terms in this order. So that will cure your arrangements in the descending powers. You get it? But what I'm going to teach you, you get your arrangement in descending powers straight away. You wouldn't have anything to cure because you think before writing. So by that, this is what we are going to do. Because we know if your variable is in the second term, the powers will be what? Will be ascending. So it means if I expand that way directly, okay, it will not give me what I'm looking for. So what do? I need to, okay, rearrange the terms because A plus B is the same as B plus A, true or false? So I will write this as, because I want my expansion to be in descending powers, it means my term containing the variable should rather be the first term. So I'll write this one as 3x, okay, plus 1, all to the power 4. Is it not the same binomial that I'm expanding?
Yes, please.
Okay, only that I have swapped the terms to achieve a particular goal. And the goal is that once my x term is the first term, if I expand, I am going to get my powers of the x to be descending. So I will get my arrangement directly, okay, as this, in this order. Okay, so now this is what we are going to do. So I'm going to write equal to. Okay, unfortunately, our first term is not 1, but fortunately, our power is still what? A positive integer. So it means we are going to quote the binomial theorem for a plus b, okay, to the power n, because your a this time round is not 1. Okay, take note. So we'll quote that one mentally. Okay, and u. So when you have that one, we know our first term will be 4 combination 0. So it will be 4 combination 0. Then your a now is 3x. Okay, to what power? To the power 4. Then your b is 1. To what power? To the power 0. Then plus. Now, professors, I hope you are following.
Yes.
Yes.
Yes,
Okay, I've
please.
quoted the formula but mentally. But if you cannot use it mentally, go and write, but a plus b to the power n is equal to n combination 0, a to the power n, b to the power 0, n combination 1, a to the power n minus 1, b to the power 1. You know all that. As for expansion, okay, at this point, okay, we should all be experts. So now you come to the second term will be 4 combination 1. Okay, and your a is what? 3x now. So it will be 3x. You reduce the exponents by 1, started from 4. So it will be 3. Then your 1, okay, the exponent will increase by 1. Okay, then plus, okay, the next one will be 4 combination 2. Okay, then your 3x, the exponent will reduce by 1, so squared. Okay, then your 1, its exponent will increase by 1, so squared. So let me come and clear this. Okay, at least I used that one to explain. It has served its purpose. It can go. This one too can go. All right, so now let's see what we are going to get. Then plus, okay, 2 more terms to go. Okay, so you get 4 combination 3. Then your 3x, you reduce the exponent by 1, so that will give us 1. Then your 1, the exponent will increase by 1, so that will give us 3. Then plus, okay, 4 combination 4. My professors, I hope you are following.
Yes.
Then your
Yes,
3x
please.
to the power 0, okay, then 1 to the power 4, all correct. Okay, so at this point, this will be equal to, the next step is to, okay, deal with the combination and the powers. So for any normal combination, 0 is 1. So I'm writing it just for, you can choose not to write it. Okay, then this one will give out, if you push the power in, you are going to get 3 to the power 4, which is what? 81. Okay, then s to the power 4. Okay, then any number to the power 0 is what? Is 1. Okay, then plus 4 combination 1 is 4. Okay, then you get 3q, that is what? 27. Okay, then x what? Q. Okay, 1 to the power 1 is what? Is 1. Then plus 4 combination 2 is 6. Okay, then 3 squared x squared, so you get 9x squared. Then 1 to the power 1 is 1 squared is what? Is 1. Then plus 4 combination 3 is 4. My professors, I hope you are following. If you push the power in, you get 3x. Then 1 cube will give you 1. Okay, 4 combination 4 is what? 1. Okay, so let me write it for, so this one too, let me put it in brackets. Okay, so 1. Then this will give us, okay, also 1. 3x to the power 0, number to the power 0 is 1. Then 1 to the power 4 is also 1. I hope you are with me, my professors.
Yes.
Okay, so my last step will be the step that I removed all the brackets. So in that case, I'm going to write therefore I can conclude. Whatever I was asked to expand, don't use this to conclude. It is this one that you were asked to expand, okay, in descending power. So it will be 1 plus 3x all to the power 4 will be equal to. So this will give you 81, okay, s to the power 4. Okay, then plus, this will give us what? 108 s cubed. Okay, this will give us what? Okay, plus 54x squared. Okay, plus, okay, this will give us 12x. Okay, then plus 1. And is it not this arrangement in this direction? So you can see that the powers of your x in the expansion they are decreasing. So in descending orders or order. Is my point well made, my professors?
Yes, please.
Yes.
Yes,
Sure.
please.
Anyone? Is there anyone here who would want? We are going to do Okay, one more. At least you know that we are going to do this, at least. Okay, so if your understanding is not perfect, make sure you ask all the necessary questions. Okay, especially in the second one, the II. All right, so I guess I can move on. Okay, so if you can move on, so let me move on to my next slide. All right. Okay, so now we are going to look at II for A and what and B. So let's look at II. So question II, okay, A. What are we given? We are given 2x plus y all to the power 4, also to the power 4. Okay, so now let's see. Okay, in this particular one, because we are interested, look at the variable that we are interested in, its powers in ascending or descending. So the variable here is x. So it means we are looking at x. So you have to concentrate on the term containing your variable. Okay, so in this case, the term containing the variable, let me pick my laser. Okay, so the term containing the variable is the first term, is that not it?
Yes.
Okay, so you should know that if you expand, okay, because your variable is in the first term and you know that the first term in the expansion, the powers will be what? Will be decreasing, true or false?
True.
True. So if you expand this directly without arranging the terms here, you know that the expansion will come in a particular form. And that form is you will get it directly in descending powers of x. Meanwhile, are we looking for ascending powers of x or descending powers of x?
Ascending powers of x.
Ascending. So that means we need to swap our term so that the x term will be where, if you expand, the powers will be ascending. So you cannot expand directly. If you expand directly, you are going to get its expansion in what? In descending power. So it means if you expand directly, you will do the B first. You get it? It will end up giving you the result for B. Okay, all right. So once my point is well made, my professor, is my point well made?
Yes, please.
Okay, very good. So this calls for rearrangement. Okay, so I know that this will be equal to what? Y plus 2x, okay, all to the power 4. Okay, because of the purpose I want to achieve. The powers of the x here should be what? In ascending, or should be ascending. So in this case, I'll write this is equal to. Okay, now what do? I know, unfortunately, my first term is not 1. So I have to use the a plus b, okay, to the power n. But my power here is what? A positive integer. So I will use the combination 1 instead of the expanded combination. So I'm going to get again 4 combination 0. Your a is y. But y to what power? To the power 4. Then your 2x, which will be your b, to the power 0. Then plus the next term will be 4 combination 1. Please help me, my professors. Let's do it together. Let's remain active. Help me, the whole class, the entire class. Let's go.
Okay. Y.
Y
Is
in
Y
brackets,
in brackets,
y,
cube.
y in brackets raised to the power,
2 to the power 2x into bracket
2x raised to the power 1,
Okay, then plus. Let's go. You are doing well.
4 combination
plus 4
Combination 2. Y squared
squared
2x
bracket 2x
squared. Okay, then plus. Let's go.
squared
Okay, 4
4
combination
combination
3.
3
To
into bracket y
the power 1.
3
2x. Okay, 3.
bracket
Then plus. Let me calm down. It
4
won't go this.
combination
So 4
4
combination
4
4. Y to the power 0. Then what? 2x to the power
4
4. My professors, I hope you are following. Is everyone with me?
Yes, please.
Okay, so your
yes,
next step, okay, will be equal to. Very good. So now 4 combination 0 we know is 1. So the one that will give us 1, I will write it. Okay, you know we are mature. So this time around. So 1, I will write it. This is y to the power 4. So that will give me, I'm pushing the power inside. So that will give me y to the power 4. And this will give me 1. I will write it. Then plus, okay, 4 combination 1. That will give you 4. It's not 1. You have to write it. If you push the power in here, you get y, okay, cube. Then, okay, then this will give, if you push the power in, you get 2x. Okay, then plus 4 combination 2 is what? 6, right? Okay, then we are going to get y. If you push the power in, you get y squared. Then 2x, if you push the power, you get 4x squared. Okay, then plus, okay, 4 combination 3 is 4. Okay, then y to the power 1 will give you y. Then this one will give you 8x cubed. I hope you are following.
Yes, please.
Then
Yes,
plus
please.
4 combination 4 will be 1. You don't write it. Y to the power 0 is also 1. You can choose not to write it. Okay, then you get 2x to the power 4. So it's 2 to the power 4, which is what? 16. Okay, then x to the power 4. So your last step is where you remove the bracket. At that point, you draw your conclusion. So therefore, your 2x plus what? Y to the power 4, okay, will be equal to, now we get y to the power 4, we are removing the bracket. If you remove the bracket, you get plus 8, okay, x, y cubed. Is that not it? I'm arranging in alphabetical order. Somebody can write y cubed x is the same thing. Is that okay?
Yes, please.
Okay, then plus, okay, then this will give us what? 24, am I right? Okay, s squared, y squared. Then plus, and this will give us 32. Okay, x cube y, then plus what? Okay, 16 x to the power 4. We are done. That is for the A. Afa.
Yes.
Okay, very good. So, okay, per the nature of the question, okay, the smart ones, okay, will deal with the B this way. Okay, so you write therefore, this will be equal, then you come and arrange, okay, write this one in this order. I hope you are with me. Write this one in this order. But like I
Yes.
said, we are going to assume we haven't done this. Okay, we haven't done this. And usually take notes. Okay, if we are giving you questions of this nature, we'll make sure that your the power here or the powers of your binomial, okay, the powers will be huge. Okay, so that if I want you to arrange in a particular order, okay, it will be stressful for you to do this before you rearrange. Meaning we will compel you to think before what's writing. Okay, so at this point, I'm going to assume we have not expanded this. Okay, so we are going to get given again. What are we supposed to expand? Okay, 2x plus y to the power 4, however, in what? Descending powers of what? And you know that the x is in the first term. So in descending powers with this one, you need to go your normal direction. You don't rearrange. So you are going to get your 4 combination 0. Unfortunately, your first term is not 1. So you can't use the special version of what the combination. Then you get your 2x, okay, to the power 4, then your y to the power 0. Then you come and write 4 combination 1. Okay, then you get what? Your 2x, okay, to what power? To the cube, then okay, your y, okay, to the power 1 plus. I guess you can continue. My professors, you can continue. Is that not it?
Yes.
Yes,
Okay,
please.
very good. Okay, so on this note, we are going to end, okay, here for that of the B. But yeah, like I said, you will continue. Okay, so continue for me. Okay, then, but if you continue, please make sure you know, you will try. If you continue, your arrangement will be 16x to the power 4 plus 32x cubed y plus, okay, 24x squared y squared plus 8x y cubed plus y to the power 4. That is the form of your arrangement. So please take note of that. Now, quickly, okay, I don't think I will give this one to you as an assignment to submit, but you will try. But I want to ask a question. So in this expansion, okay, if you expand it directly without rearranging the terms, okay, are you going to get x in ascending powers or descending powers? Should I come again?
Yes, please.
Okay, so I want the whole class. Okay, in this one, if you don't rearrange and you expand directly, okay, will your x, okay, the expansion, will it be in x in ascending powers or descending powers without rearranging? The whole class.
Ascending powers.
Ascending, because x is in
Ascending
the second term. Very good. So with this one, if you do it, you get the A. The A you have to do expand already. The B is where you rearrange. Okay, so on this note, okay, thank you very much. Prof. Giovanni, I guess your hand was up to answer the question that I asked, or you have a different question. You have something else to say? If not, then let's go
No,
and look at.
please.
Okay, we thank God. Then let's go and look at. Okay, this particular question. Let me check. Are we done? Okay, so at this point, I am going to pause. Okay, then we can go and have our water break. When we come, then we look at what we have there. Okay, so welcome back from the water break. Now let's look at questions of this nature. Okay, which I think this is the first time we are solving, okay, questions as such. So let's look at question 5. Expand each of the following expressions in ascending powers. So you underline ascending powers of which variable? The variable s. In this case, there is only one variable. Up to and including the term in, okay, s cube. Take notes. Okay, Prof. Jaden.
Sir, please, what you are sharing on the screen isn't showing so clearly.
Okay, please, who can see clearly?
Pardon?
Who can see clearly? If you can see clearly, put up your hand. So those of you who cannot see clearly, it's not from my
Sir,
end.
please, it's
Disconnect.
better now.
The issue is coming from your end. So when you have that
Yes,
situation,
please. Sir, please,
disconnect
better.
and so I just want to give you an information. Whenever you encounter this situation, disconnect and reconnect. Okay.
Okay,
So
sir.
deal with it yourself. Okay, if it persists, okay, disconnect and reconnect. All right. So okay, thank you very much for your understanding. So let's move on. So this was it. I was saying that okay, we've underlined the salient parts in the quest to protect our marks. Now, what do we do? Okay, so solution, that's the first thing that you write. Is there any major information that we can extract? 5, no, we underline. So you come and write the question 5. Okay, then you come and write A. Okay, A, what are we giving? We've been given 1 minus 3x, okay, then into 1 plus what? X, okay, to the power 6. Okay, so this is what we have. And we are supposed to expand this, okay, in ascending powers of x up to and including the term in s cubed. So this is all that you need to do. You can see that the first term that you have here, in this case, the first factor. Okay, so there's an expression I'll write equal to, okay, to introduce my steps. The first factor doesn't need any expansion now. It is the second factor that we need to expand, true or false. Okay, true, right? Okay, so in that case, you maintain your first factor because of the equal to. So you write 1 minus 3x. Then this is going to multiply the expansion of this. But the expansion of the binomial that we have here, let me see if I can change it to the expansion of the binomial that we have here. The power is what? Is positive, a positive integer. We thank God. Okay, the first term is also, the first term is 1. Okay, so it means we can quote the combination by the special form of the combination. So we do the sign of the cross, meaning we are going to do less work. Okay, so at this point, what do we do? Okay, we now proceed to carry out our expansion. But you know that in this expansion, there will be brackets, ordinary brackets. So because of that, I will introduce a bigger bracket here, which is the square bracket. So my expansion for this particular one, okay, this particular expression or binomial that I have here, I will put it in a square bracket. So by that, this is going to give us, 1 plus n combination 1, and n is 6 combination 1. Okay, then what do you write? It will be what your x, but your x is still x, so I'll write x. Okay, then plus n combination 2, so 6 combination 2. Then your s squared, your s is still x here if you compare, so you get s squared. My professors, are you with me? Hello, my professors, are you with me?
Yes, sir.
Okay, very good. Then plus, okay, our next one, which will give us was 6, okay, combination 3. Then your x is still x, so it will be x cubed. Oh, let me clear it. If you are not following, let me know. You know your class test is pending. All right, so 3. Okay, then plus. Okay, so let's see. Am I supposed to introduce the next term?
No, please.
Okay, why? Why shouldn't I introduce the next term or the next terms? Okay, Prof. Giovanni. Prof. Giovanni, unmute and respond. Okay, Prof. Nana Safo. Nana Kwame Osafo.
Sir, please, according to the question, it said that you should write it in ascending powers of x up to the third term, the x raised to the power 3.
Okay, so up to the x raised to the power 3. That is what you said. Okay, very soon you know. Okay, I will see if I can play on your intelligence. Okay, so very good. So per what we have here, we are going to, okay, ignore the other terms and represent them by ellipses. Take note. Okay, so even with this one, you can see that I didn't introduce, ordinarily, I should have put this in bracket, this in bracket, and later go and push in the powers, but I know that it will end up giving me the same result. Okay, so I've dealt with it maturely. So in that case, this bracket here, you can still use the ordinary bracket instead of the square because you can't see ordinary brackets inside. I hope my point is well made. Hey, Prof. Wilfred, is your hand up because of the question I asked previously?
Say please, sorry, said that we should raise our hand if our connection is good. That's why.
Okay, so that's the old one. Then you should be tired by now. All right, okay, so let me clear this and equally clear this and do the right thing. Okay, so let me use the ordinary bracket. Once you know you are going to introduce inside bracket, that's where, okay, the outer bracket. Okay, but we didn't introduce that, so let's do the right thing. Okay, so ordinary bracket, because there cannot be square bracket if you don't have ordinary bracket. Okay, so now at this point, this is what we are going to do. This will be equal to, okay, you keep this one minus 3x, then we come and expand this. Okay, we are not through with expansion. So 1 plus any normal combination, 1 is a number itself, so 6x plus 6 combination 2 will give us my professors.
15.
Okay, so 15, okay, x squared. Okay, then 6 combination 3. You shouldn't waste time on this. This is just calculator work.
Okay.
Come again.
20.
Oh, your network is not, I can't hear you. 20.
20.
Okay, so 20s cubed. Am I right? Then plus what? Your ellipses. Is that clear? Okay, so now what do we do? Okay, the question is in our comfort zone. You come and take each term here, then you multiply it by all the terms. We are supposed to expand, so it means your final answer, you shouldn't see any brackets, from the core math perspective. So this will be equal to, okay, so you take this one multiplying the whole of this will give us all that we have here. Exactly the same thing. So 1 times this will give us 1 plus 6x, okay, then plus 15, okay, s squared. My professors, I hope you are following. Plus 20x cubed. Are you following, my professors?
Yes,
Then
please.
now you come and multiply all the terms here by negative 3x. So let's see. So plus, oh, did I say plus? It will be minus, forgive me. All right, so let me equally. So this will give us, okay, minus 3x times 1 will give us minus 3x. Okay, then minus 3x times 6x will give us minus 18x squared. Am I right?
Yes.
Okay, minus 3x, okay, times what? 15x squared will give us what? 45 minus 45 x what?
Q.
S cube, is that not it? Okay, so then minus 3x times 20x cube will give us minus 60x to the power 4. Am I right?
Yes, please.
Okay, but you can see that you are not interested in x to the power 4 term. Are you? Are you?
No, sir. Please.
Okay, so it means that term will now come and be part of the ellipsis. So it will be plus what's your ellipsis. Point well made, or I should come again.
Well, me.
Well made. So you can see that when we were removing, so after we have removed, okay, our brackets, remember we said usually after removing your final bracket, there will be like terms for you to combine. So where you are going to combine your like terms, that's where you draw your conclusion. Or even someone who is smart can write therefore here, okay, and comment. So in this case, I'll write therefore, then whatever I was asked to expand, which is 1 minus 3x, okay, into 1 plus x to what power to the power 6 will be equal to only a constant term, which is 1. But x term, do I have? Yes, I have one s term here, another s term here. So that will give me plus 3x. Do you agree? Okay, I have s squared term here, another s squared term. So it will be 15s squared minus 18s squared. So that will give me minus, okay, 3s squared. Do you agree?
Yes.
Okay, then the s cube, you have two of them. This 20s cube, then minus 45s cube. And that will give us what? Minus 25s cube. Am I right?
Yes, please.
Okay, then plus your ellipsis. So this will be the expansion of this in what? Ascending powers of x up to and including the term in s cube. Afar. Okay, very good. All right. So this one basically we said, okay, if you expand up to the binomial expression that you have there, that you are expanding, if you expand up to, okay, the term that you are interested in, you introduce your plus ellipsis. However, when you are going to do your final expansion, there will be terms that, okay, because of the expansion, or yes, in the term that you are interested in the question, okay, you are supposed to discard in your final expansion, just as you realize here. When we expanded this, we saw that any term that was beyond s to the power q, or s3, s to the power 3, which is s cube, we didn't write it, and we have to come and introduce that one, okay, with what the ellipses that we have there, or by the ellipses. That's all. So the same approach that we are going to use to do that of what? Of the I think I'm going to skip the B, then we'll do the C. Is that okay with you? Or we should do the two? Should we do both?
Yes, please. Let's do both.
Yes, sir.
Okay, all right. I didn't know why I gave you this blank. Okay, check. Okay, so B, what are we giving? I can choose not to write the giving, and here I'm going to deal with it maturely. So I'll write there for, okay, then I'll write 1 plus 2x, okay, into 1 minus x to the power 10. This will be equal to, okay, this I won't expand, so it will be 1 plus 2x. Okay, then come and expand this. Fortunately for me, my power is a positive integer. My first term is 1, so again, I am going to use, so by this one, because it's negative, I will introduce brackets. So my outer bracket will be a square. So if you expand this, I will get 1 plus, okay, 10 combination 1. My professors, are you with me? But your x this time round is not x, it's minus x, so you have to put it in brackets. Is that clear?
Yes,
Okay,
please.
then plus 10 combination 2. Okay, then minus x squared. So minus x in bracket squared. Then plus, okay, 10 combination 3. Okay, then what do you write? Your minus x what cube. Okay, then plus your ellipsis. Is that not it? The advice given so far. Professors, are you with me?
Yes, sir.
Okay, so on this note, this is going to give us, this will be equal to, then I will still have my 1 plus 2x. Immediately you ignore this first factor and you write only this. This will not be equal to that. So it will be m0, a0. So always write the first factor that you are not expanding for your equal to be valid. Take note. So at this point, the next one, I am going to push in the powers. If I push in the powers, I'm not going to remove the brackets, or I can push in the powers and remove the brackets too. But I'm going to go strictly by what we've been doing so far. So brackets will still be inside. So I will introduce my square bracket still. So 1, then 10 combination 1 is 10. Then if you push the negative in to give you, the power to the power 1 here, you get this. Then plus 10 combination 2 will give us, professors, let's go, let's go, let's go. Okay, 4, 5. So you are going to get 45 here. Okay, then minus s, okay, squared. If the power comes in, it will give us, okay, s squared. Okay, then plus 10 combination 3. Let's go.
120.
Okay, 120. Then, okay, negative x cubed. If you push the power in, then plus what? Your ellipsis. Okay, all correct. Okay, so now this is going to be equal to, you keep your first factor again, 1 plus 2x. Okay, then this time around you are going to remove the inner bracket. So the outer bracket will take the ordinary form. So it will be 1, then minus 10x. Okay, then plus 45s squared. Okay, then minus 120 x cubed. Okay, then plus your ellipsis. All correct. My professors, are we fine?
Yes, sir.
Okay, so the next step we are going to, okay, remove, okay, the brackets. So by multiplying each of the terms here by 1. So let's see, we are going to get the whole of this. Okay, so I didn't want to go to the next page, but I'm compelled to. Okay, didn't go there. So let's go, you help me do that. So we are going to, if you expand, you get whatever that you have there will be equal to, okay, 1 minus 10x. We are multiplying, okay, each of the terms here by 1. So you'll be left with, it will be the same thing. So 45s squared minus 120s cubed. So that's what we are going to write. So plus 45x squared minus 120s cubed. Keep your ellipsis. Okay, later, okay, you introduce it at the end when you get your other terms of interest. So let's go. The other one will be 2x multiplying all the terms here. So it will be, I know all the terms here. So each one multiplied by 2x. So this 2x times 1 will give me 2x. So plus 2x. Okay, 2x times this will give me minus 20x squared. Is that clear?
Yes,
Okay,
please.
2x times this will give us 90x cubed. Am I right?
Yes.
Okay, then this is a term of interest. You write it. Okay, then 2x times 1 will give us what? 240 minus 240 s to the power 4. But we are not interested in s to the power 4 term, are we?
No.
No. So you can now introduce your plus, then your ellipsis, which will be, okay, your terms. So it should be only 3 dots. Okay, take care of the terms that are not of interest to you. So at this point, after you've expanded, remove the brackets, your final stage will be where you combine like terms. So at that point, you can draw your conclusion. So therefore, whatever that we're asked to expand, which is 1 plus 2x, okay, into 1 minus x all to the power 10, okay, will be equal to only one constant term, so you write it. Then 2 terms in x, this term and this term. So minus 10x plus 2x, and that will give us minus 8x. Am I right? Okay, then we come to the s squared term, 45s squared minus 20s squared, and that will give us what? Okay, plus 25x squared. And let's come to the s cubed term, minus 120s cubed and plus 90, okay, s squared, and that will give us plus, okay, 30x, okay, sorry, minus 30x cubed. Am I right? Okay, then plus your ellipsis. Afan. All correct, my professors.
Yes.
Okay, very good. So for now, this is the basic information that you need. So with this one, having done the B, okay, I'm only going to walk you through how to do this. Okay, so this one, you keep this one, come and expand this also up to S, okay, Q. Then later you go and distribute. Each of the terms here, you multiply by the terms that will come here. And the expansion here will equally be easy. Okay, so I will get to know whether you understood, okay, exactly what I said from this. So possibly this will be, I think I will give you this as an assignment. Okay, but I've told you, if I say that this is going to be an assignment, wait for me to put it on the platform before, because sometimes I might change, okay, it a letter, maybe the question number and what have you. Okay, so don't do any question that I haven't put on the platform and submit. You can do it on your own, but don't submit. Okay, I hope I have made my point very clear. So that will be it for the question 5. Now, okay, question 6. And this question, I will pick, okay, this one, I want to see, I will just guide you and see how best you can deal with it. Okay, but you can see that everything is in red. Most likely, this will be the question, okay, that you will see in your project work, your team assignment, which is on its way. So I'm only going to guide you. So this is it. Okay, so solution to question 6. Listen attentively. Okay, so question 6a, what are we supposed to do? Expand each of the following expressions in ascending powers of x up to and including the term in s cubed. So again, ascending powers of x up to and including the term in s cubed. So this is it, and it will not always be s cubed, so don't assume it will always be s cubed. Okay, so with this one, what are we giving? Let me help you. Okay, I won't do it fully for you because I want to see your inputs. Okay, plus s squared, okay, to the power 6. Okay, all right. There's an expression you introduce your terms with equal to. How many terms do we have in bracket here? How many terms, my professors?
3.
3 terms. So you
Okay.
can see that this has gone beyond what we know. We only know how to expand 2 terms to a certain power, but here you have 3 terms to a certain power. A trinomial to a certain power, not a binomial to a certain power. But don't worry at all. Okay, you don't have any reason to worry. Anytime you have 1,000 terms, okay, you can always write it as 2 terms if you like. Okay, if you are interested in 2 terms, if you like, it will be, and let me say 100 or even 10. I have 10 terms. It will be your first term. You can consider your first term as a term and all the other 9 terms also as another term, so that you will look at that as 2 terms. So indirectly, I'm trying to say that if I have A plus B plus C, I can see this one as A plus B plus C. In this case, I've considered this as 2 terms. 1 term, 2 term. Is it not the same expression?
It is.
is there. So what you need to do is you need to come and write this one as 1 plus, okay, then x plus what? S squared all to the power 6. Is that clear?
Yes.
But who wants me to come again? Let me close this bracket. Who wants me to come again? Okay, Prof. Giovanni. All right, no problem. So what you need to do is you have 3 terms. Just group them into 2. Okay, you have 2 terms. So someone can group it this way. First 2 and the last. Okay, then maybe the last 2 and the first. But the last 2 and the first will work because as you treat this as binomial, you see that your first term will be 1. So if you are quoting any binomial theorem, you quote the special one, which you always know that you write less. I hope you are with me.
Yes, sir.
So that's the more reason why I grouped it this way. The first and the others. Okay, so at this point you should be able to. So indirectly, at the normal circumstance, the right mathematical way of writing this to change this one to the square bracket because you have inner bracket to be the ordinary bracket. But that doesn't mean if you use the bigger, okay, ordinary bracket, you'll be marked down. Only that I want you to know the writing and let's learn to do the writing. So now, originally a trinomial, now you have a binomial, is that not it? So this is what we are going to. This is where the algebra will be a little involving, but okay, it's not too complex for you to relate. So this is it. If you were quoting this one, it's like the whole of this one, this is 1, and the whole of this is x. It's like you have your 1 plus x to a certain power n. Okay, so if you are supposed to use this one, your power being okay a positive integer, you quote the combination 1. Your first term being 1 will tell you that you quote the special one. So if you expand this, you are going to get 1 plus okay your cis combination 1. Then your x, but your x is now the whole of x plus s squared. Do you agree?
Yes.
But all to what power?
1.
To the power 1. Okay, you can choose not to write it. My professors, I hope you are following.
Yes.
Okay, if you are not following, let me know. Remember, I'm here because of you, as I always say. So now this has served its purpose. So let me clear it to create more room. So maybe, okay, so then plus the next term will be cis combination 2. Then your x, by your x is now what? X plus s squared, but it will be, you raise the power, okay, you increase it by 1, so 2. It will be s squared. Then plus, hey, let's go. Cis combination 3, then your new x is x plus s squared, okay, cube, am I right?
Yes, sir.
Okay, then plus, can we end here?
Yes, sir.
Okay, so plus what? Your ellipsis. Okay, then what do you do? This will be it. So now, okay, what you need to do is, okay, this is a binomial. You should know how to square. This is a binomial. You should know how to. I told you that maybe I would. Okay, let me do the first one for you. Okay, maybe it will guide you to do the next one. Okay, I wanted to see your input, how smart you are from your team assignment. Okay, so at this point, you know, the next stage is to push the powers inside and deal with the combination. So that will give us 1 plus, okay, 6, because any number combination, 1 is the number itself. This is the power 1. If you push it inside, you can still get s plus s squared. My professors, are you with me?
Yes.
Yes,
Then
sir.
plus, cis combination 2 will give us,
15.
okay, 15. So we are going to get 15. If you push the power, now you are expert in terms of a binomial squared. We did a lot in core math and even in elective math. So you know that if I have a plus b all squared, this will give me a squared plus 2ab plus b squared. Abi, is that not it? So my a is now x, my b is now s squared. So if I'm expanding this, pushing the power in, I will get s squared, my a squared will give me s squared, then plus twice the product of this and this. The product of this and this will give me s cubed. Twice that will give me 2s cubed. I hope you are following my professors.
Yes,
Are you
please.
following my professors? Is
Yes.
everyone following?
Yes, sir.
Yes, please.
Okay, then plus Okay, my b squared, but your b is s squared. So it will be s squared squared. That will give you s to the power 4. Do you agree?
Yes.
Okay, so now we come to 6 combination 3. I'm waiting, my professors.
20.
Okay, 20. All right, so that gives us 20. Okay, now let's see. I will give you a very vital information pretty soon. Okay, now let's go. Okay, if we are expanding this, you are now expert in binomial to any power, even cube. Okay, so this will give your first term will be this 1 cube because the coefficient will be 1. Okay, it will be this 1 cube. I hope you are with me. If I have a plus b, okay, cube, this is equal to a cube plus 3a squared b plus 3ab squared. Okay, you get it then, plus b cubed. Am I right? Hello, my professors. Do you want me to come again, or my point is clearly made?
Please come again.
Okay, you should know how to expand any binomial. So let's go a binomial, assuming you are using the Pascal triangle because the power is what? Is small. Okay, you know that you are going to get the coefficient of the first term will be 1. You can choose not to write that one. Then it will be your term here as, okay, your term that you have here. I mean, that's what we have here. If you expand a binomial cube, you should know that, okay, it will be a squared plus 3a squared b plus 3ab squared plus b cubed. By now, you should know this. If you don't know it, you can still go and do your crude one. You know that what you have here is the same as ax plus x squared, okay, into x plus s squared all squared. But s plus s squared all squared is what you have. This is like you have s plus s squared into what you have here. So you come and write it there, which is the s squared plus 2s cubed plus that. Then you later go and expand. But in this way, I will not do that. It will be a waste of time because I'm matured. So I know that it will be my a. This is a. This is b. A cube. Okay, so a is x, so s cube. Okay, then plus, and if you are matured, you will know all your other terms, the powers will be more than 3. Do you agree? Okay, if I do 3, let's do it and see. 3a squared, but your a is x. Okay, then b is s squared. Do you agree? So that will give you 3x to the power 4. You are not interested in x to the power 4. So all the other terms, the powers will be more than 3. Because you know if you expand, the powers will be increasing. You get it? So this will be the list, s cube, which you are interested. Okay, so once you are interested, you write it. The other term that you are not interested, don't write it. Don't waste your time to write it. Is that clear? Even with this one, we could have, okay, decided not to write the s to the power 4 because it's not a term of interest to us. You get the point?
Yeah.
Okay, so but we'll take care of that. When you expand and you get s to the power 4, we'll write it the next term, and it will be part of the ellipses in the final stage. So that will be equal to, then we are going to get 1. Now we are going to remove the brackets here, plus 6x. Let's go. So this time this 6x. Okay, it's a term of interest, plus 6s squared. S squared is a term of interest. We write it, plus 15s squared, a term of interest. 15x, so it will give us 30s cubed, a term of interest. Am I right? 15 times s to the power 4 will give us 15s to the power 4. S to the power 4 is not a term of interest. I will write it. Okay, it will later be part of the ellipses. Then plus, okay, 20 times s cubed, and that will give me 20s cubed, a term of interest. Then plus my all the other terms that are not of interest to me, which will be s to the power 4 going. Is that clear, my professors?
Yes, sir.
Okay. Any questions at this point before we move on? Any questions? Okay, so now what do we do? Okay, the last step is where we draw our conclusion. That is where we are going to combine like terms. So 1 plus, therefore 1 plus x, okay, plus s squared to the power 6 will be equal to, I've told you, so what do we do? Only one term, constant term 1. 2 terms in x, or only one term in x. Okay, so I write it and that will give me plus x. Okay, s squared term, 2 terms in s squared, this and that. So that will give me plus 21 s squared. Okay, 2s cubed term. So I add and that will give me 50 s cubed. Then I bring my plus ellipsis. Afa, hello, my professors. Is that
Yes, please.
clear?
Yes, please.
Okay, so here, any term that is not of interest to you, when you are expanding and you get that term, you ignore, you represent it by ellipsis. Okay, that's all that you need to know. So on that note, I'm not going to touch this. Even this one, I told you, I was supposed to have explained up to this point where you can write it as a binomial, then I should have left you at that point. But it seems some of you were vigorously, praying. So I was touched, my heart was touched to complete this, and I have done that for you. So that explains this. So this one, you write this one as 1 plus, then the whole of this in bracket to the power 5. Then you go and deal with it. Afa, my professors, is that clear? Are we all fine?
Yes, sir.
Augustine, I don't get your. Okay, I guess, Augustine, are you fine now?
Yes,
I
please.
was reading the chat. You are fine now.
Yes, please.
Okay, all right. Okay, so that will be it. Okay, for what we have here. So let me check. Okay, the time left, whether I will be permitted to. Okay, so let me see whether the time will be sufficient. Okay, at least let's handle this. Even if you are not able to complete it, and maybe shouldn't I give this one to you as an assignment? Yes, because I have to encourage you to read. Okay, so on this note, okay, this will be it. Our last, okay, one should be finding the general term of a binomial expansion. Okay, so what I will do is maybe I will send you a recorded version, okay, of this one. Okay, then these two are known questions. So if you do your research well, you should be able to, I'm talking about this one and this one, they are known questions. So if you do your research work before you do your team assignment, you will get the solution and maybe appreciate the solution. Okay, and maybe the solution that you will see will be, uh, let me say, will not have exactly the way I have told you to present your solution. So you give your touch to the solutions that you see, wherever you see it as a result of your research. Okay, and then last one should have been finding the general term of a binomial expansion and using it to find a particular term. So that one, I will do the video and send it to you to watch and use it to do your project work, your team work. After this class, I will put the new team on the class page. Okay, you check your new team, then you move to those teams. Okay, if you happen to be your original team, then you will be there. If not, you exit your old team, then you move to your new team. Is that clear?
Yes, please.
Okay, all right. So at this point, any questions? Any questions? My professor, is everyone fine?
Yes,
Yes,
Okay,
please.
please.
all right. Okay. So on this note, thank you very much. Okay, God bless us all and have a wonderful weekend.